Greetings, awesome dynamic students. We want to do the reading questions for 16.6. This is the Instantaneous Center of Zero Velocity, or the IC chapter. So the IC is a really useful method for finding the velocity at different points along a rigid body. So let's go ahead and get started here. First question is, where is the instantaneous center of zero velocity for a wheel rolling without slipping? And this is a important question because this is one of the most important examples of instantaneous center of zero velocity. And most of y'all said it was the point of contact of the wheel with the road, yes. So if you recall from physics 1, we talked about this too, except for we didn't call it the instantaneous center of zero velocity. We called that point the instantaneous axis of rotation. But they are the same thing. That is what they are. All right. Let's go to the next question here. To find the instantaneous center of zero velocity, you choose two different points, A and B, and then find and draw their velocity vectors. Then what do you do? Someone who has two thumbs and remember to do the reading this time, then is excited about it. They say you then extend the perpendiculars from the velocities to their point of intersection, which is the IC at that instance. Yes, that's right. So that's one method to find the IC whenever you have velocity vectors at two different places that are not along a line or not parallel, okay? There's another example where they are, if the velocity vectors are parallel or anti-parallel, then you have to use a slightly different method for that, okay? And I solved one of these in an example problem, so if you are curious about that, seeing that in gory detail, please take a look at that example problem. For the next question here, for a board propped against a wall but sliding down towards the floor, where is the IC relative to where it touches the floor? And it's at this, and most of y'all said something like, it's the same height as the propped height position, but the X position is the contact point on the ground, though. Yes, that's right. So it's directly above the contact point, and it's directly across from the contact point on the wall horizontally. And that's the intersection of those 2 points. So you just have to draw those two velocity vectors per the previous description. All right. Can the IC be used as the axis of rotation for the full motion, generally as a function of time? And this is a question probably not explicitly answered in your book, but it's implied heavily. And the answer is no. And the reason is because this person says, the dude says, because the IC only represents the velocity of a system at a specific point in time. That's right. So the IC is the instantaneous center of zero velocity. You can't use that same point as the axis of rotation in general going forward. Now, it is possible, there's some subtlety here, which we are not going to really get into in the examples, but if you, generally you can use treat something as rotating about an axis through a fixed axis, but then you have to consider translation plus rotation. So in general, if you have a fixed axis that's fixed in an inertial reference frame, then you can use that as an axis, but you then have to consider translation plus rotation. But the IC is used for just considering rotation only. So those two ideas are not quite 100% compatible there, okay, because the IC is used for just rotation. And alternatively, you may also choose an axis that is fixed in direction, but the axis itself can accelerate. So like, for example, a rolling wheel, maybe the wheel is rolling down an incline. If you use an axis through the center of mass of the wheel, the center of mass of the wheel is accelerating. But the orientation of your axis, the direction of your axis is not changing. It's just that the location of the axis is accelerating. And that you can use most of the equations for rotation and translation. But again, you're doing rotation and translation. So you have to be careful about, you're considering both rotation and translation. The IC is used when there is only, we're just considering only rotation, and it's only good for that one instant, and that IC may change. The position may change to the next instant, okay? So you have to consider that, and that's built into the name. The I in IC stands for instantaneous. All right, enough blabbling on. Let's go on. The IC can be used to determine the velocity of any point in the body at an instant in time. Yes. So it's used to consider the body as pure rotation, and that is why we use the IC. And of course, we consider pure rotation around the IC, and then we use V equals R omega, omega being the same for the entire body, but the V's being different. Okay, and then the R being from the axis of rotation to that point. All right, any points of confusion or questions you'd like to discuss in class? Just a little confusion about the IC. Can it be used as the axis of rotation for the full motion generally as a function of time? No, I was just hoping that you would pick off the obvious answer and not get into the weeds too much, that the IC is only good for an instant in time, and then the IC may change location, so you can't use it as the axis of rotation for the generally as a function of time. So because it changes direction, changes location. It's only good for an instant. All right, hopefully this was clear and helpful, and you guys did really well on this, and we only have a few more assignments. So as always, if you have any questions at all, let me know, and I'm here to help you. So I'll see you guys later. Bye.